I've copied your code in, and I put 3 in for the parameter for Pascal's triangle. If I run this, then this gives me this. Let me put 5 in there for 5 rows. And we got 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. And then we got 1, 4, 6, 4, and 1. Let's see what the next one is. Okay. Now if you look at the rows here, 1 plus 2 is 3, and 1 plus 2 plus 3 is 6. 1 plus 2 is 3, or 3 here, you can think of it that way. So when this puts a 1, 5, 10, 10, 5, and 1, you see symmetry all over the place, numbers being added together. 1 plus 3 plus 6 gives us 10, or even here you can see some patterns. But anyway, that's not what I'm wanting to show, because I definitely am not an expert in Pascal's triangle. I know what it's used for. If I take x minus 1 squared, that's x minus 1 times x minus 1. That gives us x squared minus 2x plus 1. There's a 1 here, there's a 2 here, and there's a 1 here. Now if I take x minus 1 to the third, that's going to be x minus 1 times x minus 1 times x minus 1. So we're going to have x minus 1 times x squared minus 2x plus 1, which gives us x to the third minus 2x squared plus x minus x squared plus 2x minus 1, which gives us x to the third minus 3x squared plus 3x minus 1. Now ignoring the signs, you see we have 1, 3, 3, and 1. 1, 2, 1, 1, 2, 1, 1, 3, 3, 1, 1, 3, 3, 1. This allows us to do a binomial expansion. And always, whenever I do run across problems dealing with that, then I have to go read up on the Pascal's triangle to see how to figure out how to build this. But this is just code that shows you how to get that triangle. And it allows you, in theory, if you got a big enough triangle, if you got x minus 1 to the 10th power, then you do not have to sit there for 2 hours multiplying that together, hour or whatever it is. You can just go ahead and write down your answer. Now code-wise. Okay, I'm passing in 6. So it comes here, says if n is equal to 0, returns this. If it's n equal to 1, returns 1. Else comes down here, and new row is equal to 1. And then result is equal to Pascal's triangle. And this is recursion. It calls itself. But it's passing in n minus 1. Now n is 6 to begin with, so it's passing in 6 minus 1, which is 5. And so at that point, when it calls this Pascal triangle, it's up here, and it's going through this. Let's put 2 in. 1's probably too trivial. Okay, so it comes up here. If n is equal to 0, it's not equal to 1. It's down here. Got new row is equal to 1. And then it's calling this, so it's doing 2 minus 1. So it's coming up here and calling that. And if it's n is equal to 1, it's returning 1. So it's returning 1. Now when it's doing that, it's assigning it to result. At that point, it continues with this this code here and looks at the previous row and that's kind of obvious what it's doing. For I in range length to previous row minus 1. Okay, and it's appending it then. So instead of having a appending it, okay, I see what it's doing then. So then it's putting these together with commas in between them. So down here, when you return the result, the answer is equal to Pascal's triangle, and I print the answer. Then instead of just printing the result, you could take this and access different parts of the answer. So, like let's see what this gives us. Print the answer. And that gives us our first entry. So we could, like if I put a 5 in here, I could have a for statement. So for x in the range of mixing up my programming languages. 5, I think that's 0 to 4 if I remember right. Then we'll print x. 0, 1, 2, 3, 4. Okay, so then you can get a little bit more of the Pascal's triangle feel. You could even take that and treat it as a string, such you pad it with spaces so that it would be lined up correctly. That's probably overkill though. But what this is doing is, again, calling itself. And sometimes recursion is the best way for it to call itself.